Good morning, viewers. Welcome to my YouTube videos on high physics norms.
Hello students, today I would like to discuss about the mechanics, basics of mechanics. First of all, what is a mechanics and what types of branches it consists. Here, mechanics means it is a branch of physical science dealing with the behavior of matter under the action of forces. Now, the mechanics, which is classical mechanics, or it is also known as Newtonian mechanics, it is of three branches. Number one is kinematics. So, what do you mean by the kinematics? Kinematics means it is the study of mechanical motion of bodies without considering the cause of motion, like forces interacting bodies. That means if the body is in motion, how it is in motion, we don't know. We don't want that. That type of study is nothing but the kinematics. Kinetic means motion. If you see the dictionary, kinetic in the sense motion. Say next, number two is dynamics. What do you mean by the dynamics? Dynamics, it is a mathematical and physical study of the behavior of the bodies under the action of forces that produce motion in the body. That means here we can explain the motion, why the motion of the body occurs with the help of the force. So if a body is there, that is, for example, if a pen is here, I am applying some force on this, that means it will be in the motion. This we can consider as the dynamics. Okay. Suppose, for example, if it is inclined plane, it is there, okay, now it is in motion. This is kinematics. We don't know the cause of motion. Simply the body is in motion. That is the basic difference. If you apply force on this body, then it is in motion, then that is said to be dynamics. Next will be the third part will be the statics. Statics means it is a mathematical and physical study of the bodies in equilibrium under the action of forces. It is related to the equilibrium concept. Okay. Next, in generally in mechanics or in physics, we use the word so many times: a particle, a body. So what is the difference between the particle and the body? That is important thing. The basic difference for this will be here. In mechanics, the word particle is used in a very restricted sense as one having negligible dimensions. So we can say that doesn't have the dimensions. Negligible, that means we can't say this much, we can't say this much. But the body possesses dimensions and can be considered to consist of infinite number of particles. That means we can say a body means it consisting of infinite number of particles. Say for example, if it is a body, it having the so many number of particles, the combination of this total particle can be considered as the body. That particle means we can't explain that. That is why, because it is doesn't have the dimensions, negligible dimensions we can say. So, but very often the word body is used for the particle also, with same restricted sense of the particle. That means you say if a body is thrown, if a particle is thrown, in generally we can consider in the restricted manner, both can be considered as same. Okay, got it. Continuation to this, what is the body is said to be rest, is said to be motion. So how can you say that what is rest and what is motion? Say for example, rest means, the definition of rest is if there is no change in its position with respect to the surrounding or time. If there is no change in its position with respect to surrounding or time, then the body is said to be in the rest position. If it changes then it is said to be in motion. Say, we can say, for example, now the pen is here. After 1 second, after 2 second, after 3 second, 4 second, 5 seconds, it does not change its position. Then we can say this is in the rest position. Say, for example, it will be moving like this. Initially, the position is here, we can say. Now the body will be moving like this. After 1, 2, 3, 4, 5, 6, 7 seconds, automatically with respect to the time, its position changes from here to here. Then this is said to be in the motion. That is the best example. That is a simple example. Okay, there is a difference between the rest and the motion. Okay, don't go for depth. Now in this kinematics, important things are equations of motion. So for these equations of motion, I'm considering a small sentence for this. Let us consider a body, or you can say particle, or simply body best, a body of mass m, but don't want one mass. So mass m moving with the initial velocity u after t after time t seconds, it travel s distance and final velocity becomes v and possess acceleration a. Now in these important terms, you have to remember this. First thing is u, initial velocity u. Generally in the alphabets u, v, w, x, y, z. That's why we can consider u is the initial one, v is the final one. Remember in this point of view. U initial velocity, time t seconds, distance or displacement s, both are same here. Why? Because this is in one dimensional motion, that is in linear motion. Okay, and final velocity v. So if the velocity is changing, means automatically it will possess some acceleration a. By using this sentence, this concept, we can get the equations of motion. So what are they? Say equations of motion are, first one will be here, equations of motion. Number 1, v is equal to u plus at. Number 2, v square minus u square is equal to 2as. Number 3, s is equal to ut plus half at square. And number 4, it will be used rarely if Sn is the distance covered by body in nth second. If they given nth second, then you can say Sn is equal to u plus a into n minus half. In sometimes LCM also you can take. So these are the 4 basic equations of motions. If you observe these equations, if in a problem basing on the data given, you have to use this equation. If you observe the first equation, velocity is there, acceleration is there, time is there, but there is no distance is there or displacement is there. That means if in the question displacement distance not given, then you have to use this equation. If you see the second equation, the velocities are there, initial, final, acceleration is there, distance is there, but there is no time here. That means if in the data time is not given, you have to use this equation. If all are given, that is the distance, velocity, acceleration, time, all are given, that means you have to use this equation. This equation is the special equation. Okay. Now for this, For a freely falling body, what happened to these equations? For a vertically projected body, what happened to this equation? In case of, for a freely falling body, so what are the conditions for the freely falling body? So if the body is freely falling like this, then you can say the initial velocity of the body is 0, but it is moving towards the ground, that is due to the gravity. That means it will possess acceleration is nothing but acceleration due to gravity. Here the conditions are initial velocity u is 0, acceleration is nothing but the acceleration due to gravity. Now how can you define the acceleration due to gravity? The simple definition for the acceleration due to gravity, small g, is the acceleration of a freely falling body due to Earth's attraction is called acceleration due to gravity. That is a simple definition represented by the symbol of small g. So its value is g is equal to 9.8 meter per second square, or 980 centimeter per second square, or approximately in some questions you can use 10 also, depending on the given condition. See what happened to the equations 1, 2, 3. So one equation becomes, in place of a you can put g, u 0. That means you will get v is equal to simply gt. What about the equation number 2? U 0, a is equal to g. That means v square is equal to 2gs. Okay. Next, what about this equation number 3? That is s is equal to u 0. That is half g t square. These are the equations. That means if you consider in place of s, h also. Why? Because freely falling means it will possess some height. Now, if it is a vertically projected body, for a vertically projected body, in this case, vertically projected means like this. If like this, that means here your velocity should be present. So acceleration a is equal to minus g. Minus indicates the direction, that is which is opposite to the gravitation of Earth. So a is equal to minus g, you can say. Simply equations will be changed to like this. V is equal to u minus gt. This is equation number 2 is v square minus u square is equal to minus 2gs. Third equation is s is equal to ut minus half gt square. This one, what about this one? This one also same. You can substitute in place of ag. That is Sn is equal to u minus g into n minus half. That's all. These are the equations of motion for a freely falling body, for a vertically projected body. So again you have to know the definition of acceleration due to gravity as we discussed in previously. So the acceleration of a freely falling body due to the Earth's attraction is called acceleration due to gravity. Simply remember this: acceleration due to gravity. Small g representation. How can you define this? Simply the acceleration of a freely falling body due to Earth's attraction is called g. So the generally g value is 9.8 meter per second square, or simply you can say 10 meter per second square. The rounding of this, okay. Or you can use this value in the CGS system. You can say that in CGS system g value is 980 centimeter per second square. You can use in the FPS system also. This is in the CGS, this is in the SI system. Now in the FPS system its value is around 32 feet per second square. It is in the FPS system. Generally here in India there is no use of this FPS system. European countries they use supposed to use that FPS system. Okay. So next will be the how can you determine the next in this topic required is time of ascent. Time of ascent. So TA simply shortcut. How can you define the time of ascent? Say here, time taken by the body to reach the maximum height is called time of ascent. So if the body is here, it is thrown vertically upwards up to certain distance, it will reach certain distance. Here final velocity becomes 0. Initial velocity should be present. So time taken from here to here. So we can say the definition in two ways. Time taken by a body to reach maximum height. Okay, this is the definition. Simply time taken by the body to reach the maximum height, where velocity becomes 0. Here time is t is equal to ta. Now it is vertically projected, means upward direction, means acceleration a is equal to, you can say that minus g. We need only time here. Which formula is to be used here? So if you observe this VUAT, that is first formula, that is from equation of motion. V is equal to U plus AT. Substituting this, will get 0 is equal to U minus GTA. From this you will get time of ascent is equal to U by G. This is the formula for the time of ascent. Next will be the, considering same thing, maximum height also we can say. Now maximum height. So this will be represented by symbol of H max. So same thing here. I am throwing a ball, a body, upward direction. It reaches maximum height where velocity becomes 0. Same condition. Okay. Now initial velocity should be present in the upward direction. Acceleration upward direction minus g. So how can we define that? How can you give the definition? The distance, the vertical distance, we better use vertical distance traveled by the body where velocity becomes 0. The vertical distance traveled by the body where velocity becomes 0 is called maximum height, you can say. Now height should be present. That means here S is equal to H. Height should be there. So which equation is to be used here? Here there is no mention there. They don't mention the time here. That means V is there, U is there, A is there, S is there. That means I can use this equation. From equation of motion, can use V square minus U square is equal to 2AS. Substituting you will get V square, that is 0 square, U square equal to A means minus G, 2G, S means H. So minus cancel, what you will get? H is equal to U square by 2G. This is the maximum height. Okay, H max is this one. Next will be time of ascent. Ascent okay. Time of descent, DESCENT. Time of descent, TD, you can say simply. Now how will you define the time of descent? Okay, so time taken by the body to fall from the highest point to the point of projection upwards. Simple definition. Simply you can say that time taken by the body to fall from highest point highest point to the point of projection upwards. Simple definition. That means here is a ball. It is falling freely like this. So S is equal to H. From H height it will be falling. That means we can say that initial velocity U should be 0. Initial velocity should, why? Because it is freely falling. That's why you can use U is equal to 0. Time required T is equal to TD. Moving downward direction, that means acceleration A is equal to plus G, the direction indication. Now we can use S, U, T, A, all are there. That means you can use from equation of motion, S is equal to ut plus half at square. Now S means H, U means 0, the total term becomes 0. Half into A means G, T means TD square. From this you will get to the cross multiplication 2H by G, that is TD is equal to under root of 2H by G. This is very important formula, that is time of descent, which is equal to TD is equal to root over 2H by G. Now we can prove ascent is equal to descent. So from this equation you can use from maximum height equation, from maximum height formula H is equal to U square by 2G. So substitute in above. What you will get? TD is equal to under root of 2 into U square by 2G into G. 2 gets cancelled. U square by G square. Simply you can say U by G. That means time of descent is equal to U by G. As we know, the time of ascent is equal to time of descent. So from this, let it be 1, let it be 2, can use from 1 and 2, time of ascent is equal to time of descent. So what you can say from this, you will get time of flight, capital T, which is the combination of time of ascent plus time of descent. So time of flight means while going upward and downward. So we can say U by G, this is also U by G. Simply you can say U by G plus U by G. Finally you will get time of flight is equal to 2U by G. The body which it remains in the air, total time in body which it remains in the air, we can call it as the time of flight. We will get the formula T is equal to 2U by G. Now we can compare with this, you can compare these equations with respect to the projectile also. It will be explained in the next class. Thank you for watching.